Hello everyone, this is Professor Amit Solanki from S&T College of Engineering and Research Center, Yeola. Today we will discuss our next topic, that is the step up chopper. In previous lecture, we have discussed about the step down chopper. In that step down chopper, we have observed that in case of step down, the output voltage is less than the input voltage. That is the main function of the step down chopper. Now today we are discussing about the step up chopper, or we can say that the step up chopper or boost converter is used to increase the input voltage level of its output side. Okay, so this is the main function of step up chopper. In this chopper, large inductor L is connected in series with the source voltage Vs, that is very essential. So according to the circuit diagram, you can see here, this is the input voltage Vs, inductor is connected in series with the voltage Vs is initial, and this is the switch, chopper switch. We can say that the switch is connected and there is a diode, and this is the load is connected. We are getting the output voltage from across this load. So step up chopper is used to obtain a load voltage higher than the input voltage V. And the values of inductor and capacitor are chosen depending upon the requirement of output voltage and current. When the chopper is on, the inductor L is connected across the supply, and the inductor current I rises, and the inductor stores energy during the on time of the chopper. That is the T on time. Okay. So these are the all about the function of the step up chopper. Now we are going to ahead about the step up chopper. When the chopper is off, the second condition is that when the chopper is off, the inductor current I is forced to flow through the diode D and load for a period of T of time. The current tends to decrease, resulting in reversing the polarity of induced EMF in inductor. So therefore, voltage across the load is given by V of 0 is equals to V plus L di by dt. That means output voltage is greater than input voltage. Okay. So therefore, large capacitor C is connected across the load will provide a continuous output voltage. In that case, diode D prevents any current flow from capacitor to the source. The step up choppers are used for regenerative braking of the DC motor. The basic function of the step up chopper to use for the regenerative braking of the DC motor. Now we will understanding the working principle of step up chopper by mode of operation. In that we have discussed there are two mode of operation. One is when chopper is on, and second one is when chopper is off. So let us first discuss the mode 1, that is the when chopper is on. According to the circuit diagram, we can say that, and we can observe that when switch is on, then what will happen? The closed circuit path is shown below. The current is flowing from input voltage Vs to the inductor and to the switch, and again to the negative side of the input voltage. This is the mode of operation or flow of path of the current. During this time period or T1 period, the inductor stores energy in it, because in that it will get from positive to negative, so it will store the energy. Now the load current will increase from I minimum to I maximum, and supply voltage applied to the load is equals to V0 is equals to Vs. That means input voltage or source voltage. These are the working concept of the chopper when chopper is on. And next mode of operation, that is the when chopper is off, or we can say that the switch is off, then what will happen? According to that, when switch is turned off, if switch is turned off, that means if we open the circuit or open the switch, then what will happen? Then the inductor current is forced to flow through the diode and load. In that case, the inductor current will flow through the diode and the load. Now the closed path circuit path will be, the path for the flow of current will be from positive Vs to inductor to diode to load and to again to the negative polarity of the source voltage. So this is the path for the flow of current. So during this period, T of the polarity of the EMF induced in inductance is reversed as shown in figure. Remember that it is inductor property to oppose sudden change in voltage. So this is the concept of the step of chopper. Now we are going to the expression for output voltage. Assume that the average inductor current to be I during on and off time of chopper. First, when chopper is on, then voltage across inductor L is equal to V. Therefore, energy stored in inductor, that is the V dot I into T on, where T on is equal to on period of the chopper. Okay. And when chopper is off, that means energy is supplied by the inductor to the load. That means voltage across inductor is equal to V of 0 minus V. And energy supplied by inductor L is equal to V0 minus V into I of T, I T off, where T off is the off period of the chopper. Neglecting losses, energy is stored in inductor, that is L is equal to energy supplied by the inductor. Now we are going to the formulas, that is the V of I T on is equal to V0 minus V in bracket I T off. Now this is the, we can find out the value of output voltage V0 is equal to capital V in bracket T on plus T off divided by T off. Now we can also write this formula is equation V0 is equal to V in bracket of capital T upon capital T minus small t on, where capital T is a chopping period or period of switching time, that is called the total time period. Now if we are going to the detail, the chopper operation, the capital time T is equals to T on plus T off. If you put this value in this equation, now the next new equation will be V0 is equal to V into bracket of 1 upon 1 minus T on upon capital T. And we can write these equations again in the next form, that is the V0 is equal to V into bracket of 1 upon 1 minus D, where D is the duty cycle or duty ratio. Okay, as I already been show here, T on upon D is duty cycle. For variation of duty cycle D, in the range of 0 to 1, the output voltage V0 will vary in the range of voltage to infinity. This is the concept for the step of chopper. Now in that we can see here the graph or output voltage for the step of chopper operation. In that you can see here, this is the current is flow from minimum to maximum, and after some time it will go to slowly the minimum point. These are the all about the concept for the step of chopper. Basically in that step of chopper there are two mode of operation. One is when chopper is on, and when second one is, that is when chopper is off. So these are the all about the concept for the step of chopper. Thank you so much for watching this video.